Hello and welcome everybody. Today is the day 15 of our Smart 25 Days Challenge, and today we are going to make a lost and found smart contract. This would be a very simple smart contract in which we would be allowing anybody to just report any lost items he found, or and anyone can just claim them, and everything would be stored on the blockchain. So it will provide a layer of security, and the person who would be claiming would be recorded on the blockchain. So it will reduce the chances of some false claims, and you can assume that this system can be used in support with the existing system in some universities or some institutions, okay, so that it may increase the security and it can help resolve the basic day-to-day lost and found issues. One more thing is that this is going to be a simple version, and I am planning that after the completion of the Smart 25 Days Challenge, we would be making some full stack dApps. Okay, so there we would be covering a detailed version of many of the smart contracts which we have covered till now in the Smart 25 Days, or which we will cover. So let's begin. Let us first of all name the file as loss and found. Okay, so till now all the basic things you must have learned, but still if you are not clear about anything, then please watch my previous videos. And if you are new, then you can watch my previous videos. So there I have explained everything from very basic. Let's call this lost and found. So the most important thing in this, just think about it. So how we are going to proceed is, first of all, let us just think in this lost and found case scenario. What is the most important thing? The most important thing is the item which is lost. Okay. So here we need to make a item struct so that we can keep the details regarding the all the details regarding item which is lost at a same place. Okay, so let us start making the struct called as item, and the properties of this struct would be this would include the address of the owner, okay, and the name of the item, the description, and has it been a boolean flag to indicate has it been found or not, is it still lost or have been found. Okay, so for keeping track of the items, we would be creating a mapping, and this mapping will associate uint, that is the item ID, to the item structs. Okay, item structs, and we'll keep this private only items. Then we would keep track of the item ID by the help of item count. Okay, so this will also act as the item ID, and this will keep the count of the number of items. Okay, and let's make some events also, item lost and item found, two events which we would be making, and let's index it by item ID. Okay, address, next let's index it by owner also. Okay, and string name, string description. Okay, and not anything else, description. Okay, then about the event item form, item ID, address, indexed, new owner. Okay. So let's make our functions, which would be to report a lost item. Okay. First of all, then to claim the item, and then to view the items. Okay. To view the list of unclaimed items and to find out about each item. Okay. So let's make a function to report lost item. String memory name, string memory description. Okay, and this should be public. So let's increase the item count first of all, so that the item ID is 1. So not 0 for the first item. Items, and if we'll increase the item count after the lines of code, so what will happen? The first item will get the ID as 0, and we want the to give the ID 1 to the first item. Okay, because that is only makes sense, not 0. Okay, but initially when we have declared it item count, so it would be declared with the initial value of 0. So that's why we are increasing that here and making it 1. So item message dot sender description. Okay, and yes, it has not been found initially, it's just lost, so false. Okay, and now we can emit the event item lost. So in item ID we will put item count. Yes, okay. In the owner it should be message dot sender, and because the person who has found this item will become the owner for the item as of now. Okay, and description. Okay, looks cool. And the first function is complete, simply done. And now let's make a function called as claim, to claim the item, claim found item. Just provide the ID, item ID. It should public to public. Okay, and the required condition should be that it has not yet been claimed. Items item ID equals to false. Okay, otherwise we'll say that the item has already been claimed. And after the required condition, what we will do is changes to the state. Okay, so item storage item, and from the items mapping get the item associated with the particular item ID. Okay, and then set the item dot found as true, and set the item dot owner to be message dot sender. So I hope it's very clear, but just to make it more clear, what we are doing here is we are first of all declaring a variable called as item in the storage, which means that the value retrieved by from here should get stored into this variable in the storage, which means that we want to make changes to the state of the value retrieved from here. Okay, and which value is retrieved from here? This value would be from the items mapping. You can see items mapping. Okay, and in the items mapping, the item struct associated with a particular event. Okay, so that event is the item ID, and we have provided that particular event. So the value retrieved would be that particular item struct. Okay, and that gets stored into this variable so that we can make changes to the state and that is why we have declared it in the storage. Okay, and then item dot found, we are setting it to be true. Okay, and then the owner to be the message dot sender of the claimed found item. So that means that the person who has claimed that item becomes the owner. That yes, I have claimed, so I am now the new owner. And we'll just also emit the event. Okay, emit the event item found, item ID, and new owner should be the message dot sender. Okay, looks fine. Then let's make a function to get the details about our item, that is get item unit, and this item ID, we just provide the item ID, and it should be a public and view function only, because we are not making any changes to the state. So it's okay. And public view address string memory. Okay, so this is what it will return. It will return the address, the name, the description, and the boolean, whether it has been found or not. So we would basically return the item struct associated with a particular item ID. Just that. Okay. So for that also, we'll just say items item items item ID, and return item dot owner and item dot name, item dot description, item dot font. That's it. So this function is also complete. And just for the last part, what we can do is, so what will happen in this is, after some time so many items would be lost and found. So we need to keep track of all the current items which are lost. Okay, we don't want to check one by one for each. Okay, this get item will allow us to check for one by one for each, but we want something which can tell us at which index which product is currently not found. Okay, so which are unclaimed yet. So we can make a function called as get unclaimed lost items. Okay, unclaimed items, and just public view returns movement and array of, because we would be telling all the items. Okay, indexes of those, like the item IDs. So that would be in an array. So the function would be, okay, right, uh, memory unclaimed items, new event with the size of item count. Okay, so here we have declared a new array, or new array of units called in the memory called as unclaimed items. Okay, and the size of that would be the item count. So dynamically we have declared that, and the size would be item count, because the unclaimed items cannot be more than the item count. Okay, so if there are only 10 items at a particular time, so there cannot be more than 10 unclaimed items. Either at max, there can be a case where all the items are unclaimed yet. So, and we have declared a variable called as count, and set it to be 0. And let's see why we have done that. even if we have not yet, we would not have declared that. uh, by doing so, by default the events gets initialized with a zero, only zero value. Okay, but let's do it in this way to just clearly indicate. And now, so we can do the same for the private id count, item id count too. Okay, make it more clear. Okay, looks good. And I equals to 1, I less than equal to item count to check. Okay, and I plus plus, yes. So after that, we would be checking the unclaimed items. Okay, so items I dot found. So not this way. So basically we are retrieving the value from the items mapping only, है ना? And the associated value with this I is the index, okay, which is acting, which is the unit, okay. And we would be checking the for each item uh, by accessing the item struct associated with the unit, and we are checking in that the found property whether it's true or false. So this will return that, and if it's true, if it's false, so what will happen is, if this items I dot found is false, that means that yes, the item is not yet found. So we would be making it true so that our condition can work properly. And this basically means that we would be getting into this if condition when the item dot found is false. And we will make claimed items count and set the I to this. Okay. And in the unclaimed items array at the count index. Okay. So uh, we would assign the value of I. So in this unclaimed items, we are basically getting, okay, those uh, indexes. Okay. And just increase the count by 1. Then, then to just pass the result, to return the result, and memory result, unit, and with the count. So basically the count what we have got from this will mean that this count will only increase when the items are not found. Okay, so items the I dot found is false, so then only this count will increase. So this means basically we have got the number of items which are not yet claimed. Okay, so we here for the result we have declared an array, and that the size of that array is the count only. Okay, and in this let's just proceed further. I equals 0 and I less than count and I plus plus. Okay, result I should be equal to claim items I. Okay, and so let's return result. So looks like this contract is complete. So as our contract is now complete, let us just uh, deploy it, compile and deploy it and test it out how it's working. Okay. So here anyone can report a lost item. Say someone found something, he or she can just report it. Name of the item maybe keychain, description, found near the admin block. Okay, and can just transact. Okay, so the unclaimed items returns one only because it's on the first. So say someone else also adds something and he adds bat and found near the M block trans. So here you can check, and if someone tries to check, you can just enter the ID. So you will see that it's not yet found. Okay, it's not yet claimed. It's false. And second one also, the owner comes. Okay, and everything works fine. So let's say someone claims item 2, item 2. So the currently the owner of the item 2 is this address, this one which found it. So now say this person claims it. So let's see what happens. Okay, so the owner gets changed and it's now marked as true, that now it has been claimed. So it has been found, it has been claimed. Okay, and you can see in the get unclaimed items, the ID of the item is now only one, not two, because two has already been claimed. So by this, we can get an idea. You must have got an idea how this smart contract can work, and you can always add some few more functionalities to it if you want, and you can test it out, try it out. And I would like to thank you all for watching this video. So we'll meet on the day 16 of our Smart 25 Days challenge. Thank you all. Bye bye.